Assalamualaikum warahmatullahi wabarakatuh. And today again, so let's continue. Okay, just now I already briefed on the linear methods. Okay? Linear methods, infinite slope, right? And also finite slope with a linear failure line. Okay? So this video, we continue with the still linear methods. But now the failure line is a circular type. It's a circular type. So let's go to the slides. Go to the slide. Alright. So this one. Alright. Note that rather than slip or straight failure line, we can also have a circular type of failure. And as I mentioned, I think in the earlier, we can either have a shallow circular failure line here, or we can also have a deep-seated failure line. So if you could recall, I think case study in the 1993 when we have a couple of building. I'm not sure you recognize or not the case in Kuala Lumpur, Malaysia. So when the building toppled, so this is due to the deep-seated failure line of the embankment. So circular failure line usually is an assumption when we have a embankment. So we can have a circular line with a no tension crack and also with a tension crack. So it means when we have a embankment here, so maybe it already induced a crack. So the crack can be filled with the water. So we need to calculate the pressure of water here. Pressure of water. So just to highlight the pressure of water in the crack, so we could refer this figure. So pressure of water in the crack is application of the lateral earth pressure that we learned in the chapter 1. So pressure of water is actually half of the gamma water. Doesn't have usually of active we have a Ka, passive Kp, but water we doesn't have any K. Height, the height is to the power of 2. So height of water, or here is Zc. Height of water is Zc. So this is how we want to define the pressure of water, the concept of lateral earth pressure. And what the difference between no tension crack and tension crack is the length of the parameter length of the circular. So note that if we have a shape of round, so we can have a radius. I hope you still remember how to calculate the periphery or parameter of the length. Pi r, 2 pi r, something like that. So here we need to define if we have sum of the theta. So here this is the theta for the length of A. So of course we need to know what is the theta. If we use in the degree, so we need to divide by 300. So 2 pi 2 r, I think. So LA. So what the difference between no tension crack with the tension crack? The LA for no tension crack is much more bigger than compared to the LA when we have a tension crack. So basically when we have a tension crack, the depth of the crack will reduce the effectiveness of the weight of soil here. So it doesn't, the weight of soil here with the area of the crack doesn't give the contribution to the total weight anymore. So the weight here also lesser compared to the weight in the condition without the tension crack. Okay. And in the circular failure line condition, we usually use the moment concept to calculate the FOS. So weight times the D, the distance between initial point of radius of failure, will become the moment of induced failure. Weight times the D is a moment that induced the failure, whereas the moment that try to resist the condition is comes from the cohesion, the soil properties, with the length, with the respective at the respective theta. So when we have water pressure here, so of course it will lead to additional factor of moment that induce the movement, adding the factor that to slide. So in the homogeneous cohesive soil, where we assume phi is 0, so cohesive soil usually clay. So when we assume phi is 0, so we can develop the FOS, which is the first factor that that try to resist is the cohesive of the soil. Try to resist the failure is the cohesiveness of the soil, the length parameter, and also the radius. So the moment that induce the failure is the weight and also the distance to the original point. Okay. Alright, so when we have a tension crack developed, either we have a water pressure or not, so it becomes a pressure that tend to the moment times the YC, the height. So this is the moment, which tend to induce the failure. So the bigger the crack, is much more danger, give more danger to the condition. But we need also check for the weight of the region, because the weight is also reduced. Alright, so let's see one example. So let's say we have a cutting in a saturated clay soil that incline one vertical, okay, 1 to 2 horizontal. It's quite not very steep one. With a vertical height of 10, and the saturated weight is given mass saturated 18. Okay, and C undrained, cohesion undrained is 35 kilopascal. So failure plane is assumed with the radius of 22 and 83 meter. Theta is 83. And you also will be given the height of the crack with the YC. Okay, note that here. I hope you still remember, in the lateral earth pressure, it is a rule of thumb. We assume the height of lateral pressure is 1/3 from the base. So if you know any distance here, you need to add with the 1/3 of the W, the height of water. 2/3, because 1/3 is from the base. So 2/3 plus H if you are given. So D also given, but moving mass is given here 3,150. So determine the factor of safety using moment method. Okay. What is the tension crack without water? So this is easy one. Use this one. This equation. Oops, no. Sorry. The next is tension crack with 50% of full water. only 50%. So how we want to calculate? Because we need to consider height of water only half of the ZW. Yeah. So substitute for the first one, S. So we see U35. LA is not given, so this one we need to calculate. So LA is 83.1. 360 to 5 at 22.83. So we can get the value in meter. So once, let's say this is X. So times the X at 22. Okay. W3150. D is given. So we can get the FOX. So similarly, we need to calculate for the tension crack, but with 50% of full water. So knowing that pressure of water is only 50%, so half gamma water, maybe we can use 10, or if in detail we can use 8.19 kilonewton per meter cube. Height of water now is only 50%, so half of 3.3 and power of 2. So we can get the pressure of water. Knowing this one, so the pressure is below. So half. So the sketching is not bigger like this one. So the sketching only, let's say this is height of ZW. So the sketching of pressure water is only half of it. And 1/3 is only 1/3 from the half of ZW. So knowing that, you need to adding 2/3 here and half of the ZW with the distance at the top from here to here. So I left this for you to solve, and you are also given with the answers, so you can try by yourself. And I think I stop here for this video. So let's see. This is also given the solution, but not for the number 2. So all the best, and we meet again next in the nonlinear methods of the slices method. Assalamualaikum and good day. Bye.